Welcome to our spooky stories series, and I am really pleased. My name is Angie Byron. I'm the head of community at Temporal, and I'm really pleased today to welcome Tio. He's an amazing #1 contributor to our community, all over the place in Slack and the forums. Also, a very wonderful individual who gave this great talk at Replay that was standing room only, people taking pictures of every slide, all that kind of thing. So, yeah. I'm going to turn it over to you and take it away to you. Oh, and sorry, for this session, if you want to ask questions or chat with other attendees, that kind of thing, please go ahead and join our community Slack. There's a link right there, and go to the events live channel. And we'll get you started in there. If you can't get to Slack for whatever reason, that's also cool. If you use the Q&A button in Zoom, I can also field your question that way. So anyway, Tio, why don't you take it away?
So yeah, so thank you very much for the great introduction. So I was already introduced. This talk originally had the title Developer Temporal Applications with Confidence. The reason for this talk is it does give talk about a bit more advanced types of topics. So it's not a temporal introduction type of talk. And the whole thing is like, as you start writing your temporal applications, whether you just starting off with temporal or already been using it for years at your at your companies and your work, there's always things that you learn, always new things. And one of the things I've done at Temporal for years is I try to help answer your questions, basically yours meaning community and also Temporal Cloud customer questions. And over this time, there are some patterns and best practices that have kind of evolved, and they come up a lot in these types of questions that users and customers just in general ask. So this talk was basically not, explicitly me telling you what to do, but kind of build up your confidence and kind of try to boost your experience level a little bit through this talk with how you approach your temporal applications, or at least things that you want to look at or consider when you do. Just in general, we do provide a lot of community help. I'm sorry, in the last couple of weeks, I haven't had a chance to do much of it because of some of the issues with recent hurricanes in Florida, but I'm trying to get back into it. But if you want to take these links, provide you Calendly links where you can sign up for free, basically use case and code reviews that you can book. And also we do, so these are customer use cases and code reviews, but also community sessions here as well. So we do design discussions, worker tuning, and then we also do observability. But most of the sessions when we talk with users, community users would end up being like, ask me any type of meeting. So whatever questions you might have, feel free to book one of these sessions and go from there. These sessions go from one-on-one to I've had some where like a whole team of like 20 people joins them and they ask a bunch of stuff, so feel free. We also do community workshops that Angie and I and Temporal are doing, and we usually post them in water cooler, and I'm sure Angie can provide, or now we have better links where we're going to post them and schedule this thing, so stay tuned for that. So for the case of this talks, let's just pick a use case. So the use case that I picked in general, it could be any use case, but this comes up a lot, is some sort of resource provisioning. And the idea behind this use case is that usually have some customers that through various UIs interact with some of the existing API service that you might have here on the left-hand side. These customers for this use case do some resource provisioning requests, whether it's provisioning hardware, provisioning infrastructure, provisioning payments, provisioning account setups, whatever that provisioning might be. But the idea is that this then provisioning request coming from the customers to maybe an existing API gets translated into workflow executions that Temporal is scheduling and executing for us. So the idea is that this API talks client API, Temporal client API to the Temporal service or Temporal cloud in this case, which then communicates with your workers through your workflow definitions to run business logic that then ends up calling different resources, provisioning resources. They're part, basically think activities that need to be invoked during this provisioning process for this customer. So it's basically kind of like a fan-out batch processing use case that comes up a lot. But the things that we're going to talk about throughout this, don't try to apply it directly to this use case. Think about in the background like your use case that you might have with Temporal, and you will probably find bits and pieces that are relatable to you as well. So when we start looking at how we're going to implement this, usually it starts without even looking at Temporal at all, or at least not directly. So the first thing that usually when we do like design reviews, so especially code reviews with customers and users, we actually look at this provisioning API that already exists first, that you can also look at some of the existing services that are going to interact with the Temporal server, whether that is on your on-prem or Temporal cloud. So what kind of questions can we ask there? The first thing we're probably going to ask is the total rate of invocation. So, and this happens all the time. It's like we ask our customers, hey, how many workflow starts are you expecting during some period of duration of time? And with that, and you're trying to access the workload you're trying to put on your temporal system. Again, always think either OSS if you're on-prem deployment, or if you're a cloud user, your cloud namespace that you have provisioned already, or cloud namespaces that you might have. But this is a very important question. Why? Because number one, we have to understand this number to provision our namespace in terms of RPS limits. Every namespace in Temporal has request per second limits that we set. And we have to understand, number one, what do we need to set that to in our dynamic configure and cloud? You walk through a support ticket through that, and we help you determine that. But on OSS, for example, one of the metrics that you can use is service errors resource exhausted. This should be on your graphs, on your server metrics, to understand really when you're starting to hit your RPS limit. Let's say you have a bunch of customers that click on a request provisioning workflows at the same time. You want to understand when this is happening. This might not cause a big problem. Rate limiting does not mean the start of the execution is not going to happen, or we possibly could. So we want to understand this. On cloud, we do provide similar counter metric, which is resource exhausted error count. And also in your worker on the SDK side, which also produce in Temporal metrics, we have this Temporal long request failure metric and Temporal request failure metrics, which can give you some indications of that. Now, just in general, if you are building out your graphs for your workers, make sure you have these two metrics available, top, left, right, and center. This will come up a lot during the slides, but are probably two of the more important metrics for troubleshooting and looking at things just in general in Temporal. The second thing that we're going to look at is, again, still not with Temporal side, but it is relatable to how Temporal works, is something called workflow ID reuse policy and connections errors. Number one is if I'm starting workflow executions from my provisioning API, I want to understand what is the workflow ID or the identity of my workflow execution that I'm going to start, and how I'm going to deal with situations where single customer requests provisioning of a single entity in my system, whether that be the customer ID or something else, or if multiple customers, for some reason, through my APIs request that. And I also want to understand how do I detect and deal with connection errors, because my provisioning API talks maybe either directly to Temporal or through some proxies that sit in between, such as an LB or some private link networks or whatever could be in between your API service and your Temporal instance. So you want to make sure that you understand when there's some issues happening between those two sides. So again, looking at metrics, in OSS, we have service errors with type. We want to understand when the service does report errors, and the first thing it's you can filter that, but operation in our case would be, let's say, start workflow execution operation. and also error type, but you can also filter it by service type as well. So we can focus, like, say, on our front-end service to see all the front-end service or client errors that are coming through. On cloud, we also have a front-end service error count. And on the worker side, again, you'll see this metric over and over again. Temporal request failure would report this. In some cases, you can also add gRPC client metrics, which is fairly useful. And we have some samples, I think, for Java. I think I finished also one for Go that I think we will add to samples. But the client API does allow you to add some sort of gRPC client library also to report auto-specific gRPC errors on top of the temporal client metrics. I mean, gRPC metrics on top of the client metrics that Temporal provides itself. So the next thing, we want to review how workflow executions are started. And typically, and sorry, this is just Java code, but you can translate. I know you might be using a different SDK, but the idea behind is that usually during code reviews, we see this a lot. We see some sort of post mapping or some sort of function or some sort of library that users use for HTTP invocations. And this is some sort of post mapping and / provision that the client invokes this API. And what the users do, they just call basically from our samples, whatever the SDK you might use, just create, in this case, and says a workflow stub, what it's called in Java, and use an API to async start this. And this is fine, but whenever we see this, for example, in code review, we kind of stop the user right there. And why? Because there's a couple of things to talk about in this case. Number one thing is, more times than not, we see you're not handling any exceptions. So, and especially workflow client start or execute workflow in Go and things like that. Make sure that you handle the error coming back in Go, and you try catch in different SDKs. You have to make sure that you can handle this workflow execution already started error. For example, in Temporal, you cannot by default have on the same namespace 2 executions with the same workflow ID running at the same time. That's something Temporal guarantees. And if you try that to start a new one, you will get this exception. And also status runtime exception is in Java, it's a gRPC exception. So make sure you handle gRPC or client errors, as we talked about as well, in whatever language you use. Another thing that is very important, in my opinion, is log these failures. And the reasoning for that is oftentimes our users and customers comes to up and say, hey, I was actually hitting very high RPS for a long time, and I was being rate limited for, let's say, 10, 15, 20 minutes. And the SDK, for a lot of these APIs is going to retry up to a minute. So a lot of these workflow starts, if I am being throttled for a very long time, possibly, or I'm having some serious connection issues, the SDK will give up at some point, and you will get these failures. At that point, if you don't log the workflow ID that you try to start, but it failed, then you can't go back and try to start those executions again. So a lot of times the user says, hey, I had this and this issue. Can you tell me which workflow IDs I try to start? And unfortunately, we can't. And then that becomes an issue in how they get hold of these workflow IDs and all the executions that the client requested, but that actually never could have ended up creating a workflow execution for it. So that's another thing. Try to log on your clients those workflow IDs, especially in case of failures. Another thing that often comes up when you start workflow executions is this temporal workflow ID reuse policy. So we said by default, you cannot start 2 workflow executions with the same workflow ID, but there's other workflow ID reuse policies. In this case, for example, we only allow clients to start workflow executions with certain workflow ID if the last execution of this workflow ID was one of the failed states, terminated, canceled, timed out, or failed itself. So you got to start thinking, which workflow ID reuse policy makes most sense for you and for your use case? And there's a bunch of them, and you can see look at your worker options and workflow options and in your SDK and read on that. We don't have to go through every single one. Now, another thing that comes up is workflow ID reuse policy and namespace retention. So temporal system, whether you use on-prem or temporal cloud, is not like a long-term storage solution, right? And a workflow execution, once it completes, it is subject to what we call namespace retention policy. When you create a namespace, or you can update it later on, you set something called a retention period, which is amount of time for this particular namespace. The completed executions stick around, long story short. So understand that this workflow ID reuse policy, as far as maintaining this workflow ID in the temporal system itself, so this workflow ID reuse policy can be actually applied, is limited to the namespace retention that you set on the namespace. So if for your use case, this workflow ID reuse policy should apply for much longer than the namespace retention, you need to actually handle it differently. Now, why would you want to have this scenario? For OSS, a lot of users set this temporal namespace retention to like 5 years, which is fine. But understand that, for example, if you're cloud users, that you're paying for the storage on cloud. So setting your namespace retention to a long time, and I think even on cloud currently, the max is 90 days, is going to affect your cost factor. So sometimes what makes more sense, if needed, consider writing the workflow IDs that you start from your clients to your custom store, let's say a Postgres or something, and check that database to determine this workflow ID reuse policy. If for use case, this has to be maintained over very, very long periods of time. And let's see. Another thing that you have to think about that a lot of users and customers don't, especially on cloud, you have to use TLS, or you have to connect using certificates. Think about client cert expiration and how you're going to, for example, do manual configuration or refreshing of your client certificates. And same applies to your workers as well. And how you're going to deal with that. Don't let your certs expire and your clients all of a sudden not being able to start executions, signal executions, and then you got a big problem, which happens more often than you think.
Quick question about that. What do you do? How do you stay on top of that? Like, how do you not get bit by your certificates accidentally expiring and suddenly like none of your workflows are working and all that kind of stuff? Because it'll look like a temporal problem, but it's actually just a certificate problem with your cloud. Like, are there strategies that people use to try to figure that out?
Yeah, I mean, a lot of times there is APIs in place. For example, in Java, there's this advanced TLS key manager where we can explicitly set a refresh period on your certificates that's less than the expiration time on the certificate that you usually use. And every SDK is going to have some sort of management. This is just straight gRPC. And I don't think we have maybe samples for all of it, but we need to check and make sure that we do, because this is helpful. If not, you just manually make sure that you update your certificates and you restart your client application. Similar with workers, you can just update maybe your certs and restart your workers, but usually some sort of refresh way, an automatic refresh is probably going to be better, because worker restarts can affect, for example, your workflow executions, especially in like performance reasons, and there's some others we'll talk about. So look at some way to automatically refresh your certs if possible. Just to stop here, last thing I'm going to talk about is workflow options. Since we're talking, workflow options are the options that you set when you start workflow executions, where you set like the workflow ID, the task queue where the execution should be running, and like workflow ID reuse policy, things like that. One thing that comes up more than not is do not explicitly define workflow retry policy. Workflows and temporals don't have a retry policy. The use cases to use workflow retries are very, very small. And we usually just, it's better not to set it. If you have that in your code, maybe reach out on Slack or something and explain your use case and we can discuss it. Another thing that is very important, probably more so than this, in my opinion, is do not set this workflow run and execution timeouts. So there's two timeouts that you can set on the client side when you start workflow execution. Both of these timeouts regulate how long your workflow execution can run before you want it to stop no matter what. So this is kind of like a termination, but in case of like a timed out termination of an execution. The reason why not to set these is your workers or your business logic is never notified whenever these two service side timeouts actually expire or hit. So at this point, when let's say I set a run timeout of 10 minutes, if my execution, regardless if my workers are up or not, after 10 minutes service is going to time out. So imagine a situation, you set this runtime out to 10 minutes, but you have a worker failure. So your executions get created, but your workflow code never runs. In that case, after 10 minutes, your execution will time out and your workflow actually never ran at all. So basically it did. So think about that. And also another thing is the workflow task timeout that oftentimes is the default is 10 seconds, and there is some rules and regulations when you should or should not change this default workflow task timeout. It's the amount of time the service is going to wait for your worker to run one or X number of lines of your workflow code. So there is some reasons to change this as use by case basis, but typically it's not recommended to change unless you really have a specific reason for that. And these are some of the two ones that I can think of. But yeah, also reach out in community Slack or ask questions here for use case specific. Okay, so this is maybe like a good breaking point if there is any questions in Slack or chat or anything, or anybody wants to ask. If not,
Yeah, so far people are being a little shy. The thing that you just talked about, though, like not arguing against yourself by setting timeouts that disagree with other timeouts and this kind of thing, that did also come up in Josh's recent talk. He framed it as like arguing with yourself, like a Jekyll and Hyde kind of thing, where so it's a thing that resonated. I did want to call out though, Ian Wilkinson on the previous topic said the temporal SA repo for cert rotation was a useful resource for me. So making sure that there was some automation there done on the certificate rotation. You don't get into the situation where oopsie doodle, we forgot about that small detail.
Cool.
Ian, if you have a link to that specific repo, oh, I think I found it here. Yeah. This one, I think. So auto cert rotation thing. Looks like it's this.
All right. So
cool. Thanks for the recommendation.
okay. So then the second thing usually we're going to look at is, again, not your workflow code, not your use case implementation in terms of the workflow or activity code. The second thing in this use case, and regardless of the use case, the second thing you usually look at, or I look at, is your resources that they're being involved. So nothing again with your has to do with your code, but the downstream resources we need to invoke during our business logic or workflow execution, in this case, for this provisioning use case. So basically, these are the APIs that, or things that our activities connect to, long story short. And the two questions we're going to ask is, first question is, are these services rate limited? And that's a very important question because and more often than not, we end up in these code reviews where people say, oh, well, we got these 20 activities. They all talk to 20 different services. We're just going to sync call them one after another on very large scale. And they don't think of this. So please, when you start your applications, think about rate limits of your downstream services. And not only that, but think about, even if you don't know if they're being rate limited, are they kind of flaky? Try to get that, even because you might want to impose rate limits on something that for example, is not going to stay up 24/7, right? So just to protect yourself. Anyways, so Temporal does give you some out-of-the-box way to rate limit these APIs. So, and the question then becomes what kind of rate limiting it is. So the first thing is let's say activity A, or the downstream service that activity A invokes, rate limited on number of concurring calls. So let's say you have a downstream API that tells you do not call me more than 10 times concurrently, right? In this case, two things that we need to do. We need to schedule activity A on its activity-specific task queue. So in case, again, on Java or Go or whatever SDK you use, when you create your activity option, set a different task queue or a unique one for that activity. Configure an activity worker that has this activity registered, right? One or more. And on the workers, set this max concurrent activity execution size. So you can still scale with this approach, because let's say we have an API that tells us do not call me more than 100 times concurrently. You can still set up 10 workers and set the max concurrent activity execution size to 10. And this comes up actually in use cases more often than you think when you have very high CPU or GPU intensive activities, where some single activity execution on a worker can sometimes take like 80, 90, even up to 100% CPU. So max concurrent, a lot of some customers that we work with and users set this even to 1. Allowing only a single activity to run on an activity worker at any time concurrent. And then they control the max concurrency by number of workers. Anyway, so that's possible to do. Now, if let's say activity A is rate limited on number of concurrent calls and we have a small workload, sometimes customers and users come and say, I don't really feel like doing this. I don't want to offload this activity to a separate task queue. I have to set up new workers for it. I have to maintain them, but I don't really have a large workload anyways, and I don't expect it to grow for, a long period of time. In this case, consider actually having a workflow execution that receives this request for activity invocation through signals from other workflows. So the idea is that let's say we have here 4 workflows. They all want to execute this activity. Instead of executing it themselves, they send a signal to the activity executor workflow. And this workflow actually can then maintain through code how many of these activities are going to be executed in parallel or concurrently. And then when it's done, the ones that it cannot execute, it can, hold on to it or basically batch. And then the caller workflow, once it sends the signal, it can await a signal back from the activity executor workflow with the results of the activity. But to understand that this really only works for small workloads, right? When you start doing large workflows, because in Temporal, a single workflow execution is limited, Temporal scales a number of workflow executions. A much better approach is to deal with number of workers and an activity-specific task queue where you can scale and do all kinds of other stuff too. Anyways, now
quick
go ahead.
question on that. Thank you, Christopher Owen, for asking the first question from the audience. Don't be shy. We don't bite. We're fine. But anyway, I know I'm a spooky unicorn, but so you can ask questions. Okay. The question is, with concurrent execution, how do you set the maximum number of workers when you have multiple processes with workers, and especially if the number of processes can change over time?
I mean, you have to, in this case, control how many worker pods you have up through either some sort of scaling where you set the max number of pods. So if you know that the max number is 10, don't scale above 10. I hope that answers the question. I don't really, that's up to you at this point because you control that. And also it's important that each worker has the same max concurrent activity execution size set, as well. But it's not something Temporal can control. I mean, of course, with this setting, you could stand up 20 workers and exceed the rate limit of the downstream API easily. So it's a bit maybe involved there, but it's not. You could always have a single activity worker that, let's say, sets this to 10 and only make sure you have a single activity worker on this task queue. And if it goes down, that you stand back up, only scale up to 1. And that's another option that you can choose. Does that answer the question, or is there any follow-up?
I think so. I got the thumbs up from Christopher. Thank you very much, Christopher, for your question. And yeah, sorry for jumping in, but it seemed relevant. Go ahead and keep going. You're doing great.
All right. So the second thing, and if there is any questions, this might be a bit of a confusing, but in my opinion, it's very important factor is It comes up probably more often than the other rate limit. It's the rate limit of the downstream API or even your database. It doesn't have to be, think about you're protecting your downstreams as far as anything goes, is the rate limit of number of calls to this API or connections to whatever over a period of time. So your downstream API or whatever you're calling in your activities tells you, do not call me more than X number over Y amount of time. In that case, again, try to schedule this activity, let's say A, on its separate task queue, and then set max task queue activities per second. And that's another rate limit that Temporal gives you out of the box, which applies on the server, applies this rate limit. So in this case, our worker tells the service to dispatch activity tasks to it and other activity workers polling on this task queue at this particular rate. So this is actually not, the other setting was per worker. Now this is on a task queue level. So the service has a rate limiting approach or implementation for dispatching tasks from the matching task queues, activity task for defined rate. Again, it's important that if you have multiple workers, they all have the same setting, because the last one coming up is going to win. So if you have 9 of them that says dispatch 1 per minute, and the 10th worker comes up and says, well, dispatch 2 per minute, and it's going to start dispatching 2 per minute, because the service is going to listen to whatever the last request is. So make sure that all your workers or your application doesn't, of the worker pods or containers, doesn't change the setting for the task queue, specific task queue that the workers, activity workers, pulling on. Now, be aware in this case of task queue partitions. So many users come and set this mass task queue activities per second and expect it to just work. And the reason is that temporal task queues have what we call partitions. And by default, they have 4 partitions. So an activity task can be dispatched, or when it's created, the history service can move it to any of those 4 task queue partitions. And each one of these task queue partitions has what we call it's going to determine what we call the burst of activities. So the idea behind max task queue activities per second is that over a period of time, the service will make sure that the rate limit over time is applied. So let's say that we say max task queue activity per second is 1 over a minute. 10 over a minute. 10 a minute. The service will make sure that there will be 10 task queues, activity task dispatch over a period of 60 seconds. But at time t0, the burst will determine how many activities can be dispatched at the same time per second. So the idea is, with 4 default task queue partitions, that you could, the first second you dispatch 4 tasks, activity task. The second, T1, second 2, you can dispatch another burst of 4. But then for the remainder of the 58 seconds, you can only dispatch 2, right? So you still get 10 over a minute, but this burst factor that is related to the number of task queue partitions is going to determine that dispatch of a burst. So you have to understand that as well. If you want to make sure that you do, let's say, 10 a minute, but you still don't want to exceed 1 activity being dispatched per second, then start playing with number of task queue partitions. And that's in the dynamic config, read-write task queue partitions. So there is some interesting use cases on that. And we had actually also customers on cloud requesting this. And in OSS, you can change your dynamic config yourself. But if you're a cloud customer, make sure you open a support ticket, and we can actually change the number of task queue partitions for your activity task queue for you. So let's make an example, because to me, this is it's important that we understand it, and this is recorded. So, a lot will reach a larger audience, and hopefully it will help. So let's say we set max task queue activities to second to 0.1, which is 1 per minute. Service over time is going to throttle the activity dispatch rate on this task queue to 1 per minute. But we can burst up to 4 a second. if we go, because the burst factor is calculated by the ceiling function on the rate, which is 0.1 divided by number of task queue partitions. So if you can Google like online ceiling function calculator, you can type in 0.1 over 4, and you're going to get a burst of 1 per task queue partition, right? So we can still burst up to 4 a second. So that is important to think about this stuff when you start using max task queue. Now, the second, even probably more important, or something that it comes as a surprise sometimes, is this thing called eager activities. A lot of users set this, calculate the burst rate, change the number of task queue partitions, but they don't see any difference whatsoever. And the reasoning for that could be that you have enabled what we call eager activities. And in some SDKs, especially the newer ones, well, the somewhat older ones, okay, they are enabled by default. In the newer SDKs, and check with your SDK, sometimes setting max task queue activities per second automatically disables eager activities. But eager activities are enabled by default. And some SDKs, especially depending on what version you use, setting this does not disable the eager activity. So make sure that you check your version, and if you don't know, just disable eager activities. It's a worker option in your worker options. Because eager activities is an optimization that's been introduced, I believe, about a year ago to Temporal, which if a worker says he wants to accept eager activity tasks, as soon as the task is created in the history service, the history service dispatches that activity task back to the worker. It does never get moved from history service to a matching task queue, but these rate limits are currently, and we are working on that actually to make it work both ways, but currently, I'm just saying, are only applied on the task queue, matching task queue level. So if you use eager activities, your activity tasks never go in a matching task queue. They're dispatched to your workers eagerly through the history service, so this is not even applied. So make sure that if you have this type of situation where you want to use this task queue activities per second, that you disable currently eager activities. Okay? Any questions around that? And anyways,
I have a question. Isn't Halloween spooky enough without having to do math? Come on, man. No, I'm just kidding.
sorry. But thankfully, there is some. I have a duplicate slide, and I'm sorry about that. So anyway, but one thing that you can, however, do, and this is OSS specific for cloud customers, please, if you see some sort of discrepancy after you said this and you don't see this applied, open a support ticket. There is a task dispatch latency count metric in OSS where you have to set task type equal activity. And then if you look over a period of time, in our case, 1 minute, let's say you set the rate interval rate of your query to 1 minute, you should only see 1 to make sure, 1 over a minute or 10 over a minute is actually applied. So you can actually measure the task dispatch latency count via metrics. And also, if you want to check if you're using eager activity execution, there is also a counter for that. It's called just activity eager execution to check that, and that's another thing you can do. All right, so enough about this. This was probably the toughest thing in this presentation. So the next thing we're also going to look at is not only if any of our downstreams are rate limited, but are any of our downstream or computations that our activities do resource intensive. So in this case, think about coding your activities that utilizes a lot of the resources on your compute, right? And in this case, you also have to think about that. So it's not only about downstream services, the rate limits, it's about also what your activities do. A lot of use cases process large files, sometimes that deal with large fanouts, even in activities, or start doing some computations that are very resource intensive, or may not be resource intensive, but they're running on a very small compute where they're utilizing like 90% of the CPU on the worker, just a single activity execution, right? Or memory, can be also a thing. So let's say activity B is very resource intensive. Again, it makes sense to offload that activity to its own task queue so we can optimize worker resources for that activity. We typically don't want this single activity or a few small number of activities that are very resource intensive to start blocking other activities or workflows, especially they're running on the other workers. So that's why the whole offloading part to a separate task queue. Another reason, well, okay, so let's keep, I'm jumping the gun here. So what are some of the important things? Monitor activity timeouts. Why? Because usually these resource intensive activities, you don't want them to time out, because if they time out, they might be retried. If they're retried, we might be running this very expensive computation again, and we don't want that. So monitor temporal request failure, monitor from the server side start to close timeout for operation timer activity task activity timer active task activity timeout. So even you can actually check activity timeouts on the server side as well. It's not going to give you the activity type, but at least will tell you that activities are retry. Another thing that you should never do, and please, like, if you take a few things out of this talk, take this one, please. Don't disable activity retries. Never set max attempt count of activities in activity retry options to 1. Always set it to 2 or 3 or a small number, because if you set it to 1, Temporal, unfortunately, cannot 100% guarantee that activity will ever run on your workers. So be aware of that. And that comes out even more, a lot. Anyways. Again, I want to go back to preventing activity timeouts, because this should be really, regardless of what you do, if you call downstream APIs, if you have resource intensive activities, preventing activity timeouts should be a priority in your case. One is observing, which you can do through temporal request failure metric, and the second thing is trying to prevent. So let's take a look at a couple of our options. The one thing that a lot of our users and customers have started doing is you can actually get the start to close time out of the activity in your activity code. So this is just in Java, you call activity, get execution context, get info, but all of the SDKs should have this. Now, once you get the start to close timeout, which let's say we set it to 2 seconds, if we start connecting to things or database downstream connections, in this case, we have some HTTP client, we want to make sure that we set a timeout on this connection that is less than the 10 seconds that we configured for activity start to close timeout. And if only connecting to this downstream service starts taking longer than our start to close timeout, we want to actually, that would cause our failure exception here, and we want to explicitly fail this activity. And what this is preventing is this HTTP client, so this line of code, or whatever you might be calling downstream for you, even a database connection, starts blocking for hours. And this has happened. This is not a joke. And this can actually cause, we even have a name for this. It's what's called zombie activities. It's basically, if this line of code starts blocking for hours, this will stay on your worker in this activity execution, in your activity executor slot on your worker for hour, 2 hours, 10 hours, as long as it blocks, right? And will never release that slot, which will take up the capacity of your worker, even leading to the point where your worker stops picking activity task anymore. And that worker is basically done, So doing this is fairly important, in my opinion, for regardless of what your activity does, if it's resource intensive or not, as long as it calls something, connects to something over whatever protocol, make sure you set a timeout on that.
Real quick, if you had not, like if somebody is out there and has not seen this talk and didn't come today, how would you know you're facing that situation? Like what would be the symptoms that you would see?
That's a great question. There's a couple of symptoms. Number one is your work. You can kind of detection for non-technical people. Okay, well, I don't want to say non-technical, for non-developers.
Sure.
Go to UI click on an execution that's not progressing, that stays in running. Usually it's detected by, oh my God, my workflow execution is running for longer. Usually it completes in 5 seconds. This workflow execution has been running for hours. They click on this execution in the UI, and on top you have workers link, a link to workers that are pulling on this task queue. In this section, each of the worker, there is like two table rows with little blue or typically a blue check mark. A workflow worker is both a workflow task a worker is a workflow worker and an activity worker. And if you click on that and there is no check mark on the activity part for the specific worker that's pulling on this task queue, but you know you have activities registered with the worker, that's usually how a ticket gets started on cloud or like a community post saying, hey, my worker, I know I have an activity registered, but in the UI says it's not polling. Now, I should add this metrics to the slide. Worker also emits a metric called worker task slots available. And through that metric, worker metric that you can actually monitor and alert on, you can detect this as well. You can detect this situation and actually alert on it. If this happens and you don't have this timeout set on this connection, the easiest thing to do is you restart your workers. However, in almost all cases, if the downstream keeps blocking, it will happen again. So we've had those cases as well. So there is metrics approach, there is a web UI approach. There is another way to do it, which is through API, and the API is called Describe Task Queue API. That also includes worker information. It's basically the same thing as in the UI if you click on the workers link, and it calls Describe Task Queue API too. I hope that answers the question.
Yeah, that's helpful. Thank you.
Yeah, so there is ways to detect this. Yeah. Okay, so this is just talking about long-running activities and heartbeats. If it's hard to heartbeat from activity code directly, can consider auto heartbeating. Okay, so this basically says that if you have long-running activities, which can happen, make sure the heartbeat, the reasoning for that is mostly that you want to detect the worker restart or the worker crashing sooner. Let's say we have a start to close timeout of 3 hours. We don't want to wait 3 hours if that activity worker picks up an activity task and then for some reason goes down in the first minute. We don't want to wait 2 hours and 59 minutes for a retry of this activity. So heartbeats can help with that. Sometimes, depending on your code, it's hard to actually know where to put this heartbeat API call. So like we do have samples. I know in Python, the samples have it. And I think in Java, we might have them, and I have to check for, for example, I think Python heartbeats through a decorator. You can just apply a decorator to activity. It will auto heartbeat. In Java, you create like with just Java thread pool, and or Go, you just heartbeat from a separate Go routine. So there is ways to do this automatically, so you don't have to kind of figure out where to call your heartbeats in the activity code, because sometimes it's hard. It's easy in loops, but sometimes it's not. Anyway, so finally we get to a part where we start talking about temporal for our use case, and the thing is going to be actually something else. It's going to be data related. So our workflows and our activities are going to, again, our workers call activities that pass data that are probably used to communicate with these APIs, but also these APIs and downstream services return results. And one of the important things to ask yourself is the size of these payloads that we're communicating between workflows, activities, and downstream services or databases or whatever, because there are payload size limits. And before we start writing our code and start talking to some, let's say, service A, we have to understand what kind of data we're talking about here. Are we talking about megabytes or what? You have to understand that. So the payload size limits are important because our implementation has to say if we're passing large data, pass references. That's usually the recommendation. If we're passing small data, pass pass it as a payload. However, there is more to it. and especially when we start talking about async activities or concurrently running activities. But regardless, and this metric comes up again, I hope you see somewhat of it. This metric is very important. So you can actually watch temporal request failure for different operations, for activities. Let's say our activity result tries to return over 2 megabytes or over the 4 megabytes gRPC limit. This is the metric that you would watch for that, for this particular API. So this scenario talks about our API or activity, the calls API tries to return large data back to the workflow as its result. This is how you would detect it. Approaches to deal with it is either a custom data converter, have the activity be paginated, so only returns like a small portion of the results each time it's called. You can have the activity write this data, let's say, to a blob store and return only a reference or a URL to the blob store, let's say an S3 URL, things like that. There is different approaches you can deal with this. So make sure that you do what happens with temporal when your activity tries to return large payload. This respond activity task completed API is going to be rejected, and it will lead to activity timeouts and activity retries. So making sure that we monitor also our activity retries, as we talked about before, becomes important. But again, this metric, make sure you write it down. Anyways, this is some sample for paginated activity results. You can write it in your language, but that's something we added. Okay, so the next question we're going to look at is max number of resources per customer or the need of parallelism. One of the things, especially in batch or fan-out use cases, we have to understand the parallelism of this use case. Are we concurrently provisioning 10 items max, or are we provisioning possibly hundreds of thousands or millions of items? Sometimes we have, let's say, customers, they're banks, they provision millions of transactions, let's say at 5 p.m., 6 p.m. at night, after the day is over. So this is a huge fan out, but we have to understand, out of those million records that we might need to process, or in this case, provision so many resources for so many customers, how many do we have capacity on our worker level, our service level, on API level, with all those rate limits? How much can we process or want to process in parallel? This will highly depend if we care if our process takes 10 hours to finish, or there is deadlines for this. And sometimes they are. We say, I have to provision a million customers within an hour, things like that. So in this case, this next section is, and I think their final sections, talk more about different approaches on what to think on how to approach possibly smaller or large fan outs or batch processing use cases, in which case this is. So what we're going to talk about is how decide how you fan out. This talks about parallel processing of batches of activities, local activities, fan out based on child workflows. That's sometimes also an approach, and a fan out using a single long running activity. And usually when you have this type of batch processing or fan out use cases, you're going to pick one of these three options. And then there is some best practices, criteria of which one you're going to pick, depending on different things you want to look at. So parallel processing of batches of activities. So this idea is that you start a batch of, let's say we provision 100 customers, we pick 10 at a time, we process 10 of them, and we have a loop in our workflow code that then processes 10 at a time. And if this is fine with your use case, and you don't care if this takes possibly forever to finish, this is a good approach. The only thing, if you do that in workflow code, make sure that you do handle continuous new, because a single execution does have limitations of event history count. So you will have to check this. Do you need a continuous execution or not? So that's just the thing. The size of combined inputs of activities in a batch. That's also another important thing. In this case, at this point, we're waiting for 10 activities to complete. But the way Temporal works is by the time we wait for these 10 activities to complete, this is actually when your worker will send a request to the service, hey, please schedule my 10 activities in a single gRPC request. So if the combined input of my activities that I'm processing in parallel exceeds 4 megabyte gRPC limit, we're having a problem. And this comes up a lot because in the documentation and people would look at samples and things like that, there is a limit of what we call 2000 parallel or what we call pending activities, meaning that in a single workflow execution, you can actually have this batch size be up to 2000 activities. However, if only 10 of these 2000 activities, their inputs combined exceeds 4 megabyte gRPC limit, we can't invoke even 10, right? So please make sure that you understand when you start running anything in concurrently or in parallel, child workflows, activities, whatever, you understand this 4 megabyte gRPC limit and how much of X you can start running concurrently before you reach it. As far as the inputs of those things go, that being activities or child workflows most of the time. So anyway,
Tio, I just want to jump in with a question on that. So what kind of a use case would you have if you were hitting those kinds of parallelism issues? Like what are you trying to do that hits things at that scale? What have you seen customers doing?
well, it could be anything, like, for example, processing banking transactions. So you have 1 million to process, and users want to process 2,000 of these at a time. So they start off, like, let's say 2,000 child workflows or 2,000 activities and wait for them all to complete. It's usually, yeah, that's the kind of use case. But it doesn't have to be a large number. It can even be, we had some use cases where a user just wants to run, let's say, a provision 4 customers concurrently, but they send such large inputs as payloads to each one of these activities that they run concurrently, they run into these limitations. So it could be anything, anything that you run concurrently. Just understand that Temporal sends these scheduling requests at the same time through a single gRPC request. And we are working internally to actually we've had this happen so many number of times, and we have customers internally. We are working on solutions for that, where the worker can actually detect this and possibly work with you, not to just fail that workflow task or the request to schedule these activities, but work with you to do it through several requests rather than just a single one. So that's coming, but currently watch out for this.
Okay, thanks.
Anyways, so another approach for fanouts could be fanout based on child workflows. Understand that these limits of event history size and count limits are per single execution. And you can nest child workflows. So sometimes this fanout or batch processing use cases can be supported by a small number of child workflows that they themselves create a number of child workflows, and you can nest them, on several layers. There's some pros and cons on that. With child workflows, you can eliminate the need to worry about the event history limits and calling continuous new. The cons could be you're creating a larger number of workflow executions. It can be harder to debug because of some failures. If you have some nested child workflows, you have to deal with how you have your workflow ID strategy to find out what child workflow execution belongs to which parent, and that parent, if it's nested, which parent that belongs to, things like that. So it does require more visibility. So there's some things like that. The third one is applicable on very, very large fanouts. So if you start processing millions and millions of execution on the batch processing, let's say we process millions of transactions, sometimes just doing them in a single long running activity is something a lot of users do. One of the things is cost, because if you start creating like 100 million child workflows, I don't know how, just I'm not a salesperson, but cost factor always comes up on that. But there's other things here, because a single activity can start 1 million child workflows and start them fine. and you can even, do many things in a long running activity. So you definitely have to, in a single activity, don't have, as far as pros goes, worry about event history restrictions or payloads, gRPC message size limits, anything. A small number of actions, cost related. Cons, it's hard to set a start to close timeout, right? Because if you want to start like 10 million executions in an activity, it's hard to know how long that's going to take, because you might get rate limited on the front end service, and this could take longer sometimes than others, depending on how the cluster is set up, what the rate RPS limits are, things like that. This activity has to heartbeat, because it's potentially a long running activity, and each heartbeat can include the last processed item. So we can actually use heartbeat details to quote unquote resume from the last item processed in case of activity timeout or of activity worker going down, which would cause an activity retry. So which fan out strategy or batching processing should I choose? It always will depend on the size of items you want to iterate. The second thing we usually recommend is to look at your resources and how much you want to actually pay for your compute power on your worker side to process this use case, millions or thousands of executions as fast as possible. So those two factors usually come in. But usually medium to large fan out using single workflow and batches of activities, large to extra large, use child workflow approach, and extra large to God knows how big, use single activity approach. I think in most cases people go with that if possible. So anyways, that's it for the slides. I know this was a lot, but again, if you're a customer, reach out. Here are links for use case and code reviews, for community sessions. I had those links before again. And yeah, Angie, please take over now.
Okay, sure. Yeah. So just to wrap things up, what's really spooky is errors. Ooh, I mean, you touched on that during your talk as well. So I just wanted to call out that we have a brand new course that just came out this week. Let me just paste the link in a couple places. So new course, error handling strategies here. And that is all about a lot of these things that Tio's been talking about, to help you with, getting out in front of trying and catching and which exceptions to look for and all this kind of stuff. So that should be a really good watch for anybody who is interested in that. It's 2.5 hours. They've got it. It looks like for Go, Java, Python, and TypeScript. So pick your language, and we can go ahead and do that. Otherwise, if you want to find all of the spooky things that we've been doing all month, you can find those at our Spooky Stories blog, which I'm for some reason having a trouble. Where'd you go? Here you go. Yep. Okay. And so if you want to go to all spooky stories, you can find those at our blog. And there's a brand new one that was literally just posted while we were on this very call, which was Daniel Abraham's talk the other day about spiraling deployment complexity. So I just want to say this is Daniel Abraham's talk on spiraling deployment complexity. We now have that in both a video and a blog post. We'll turn this resource into a video and a blog post as well. Yeah, I just want to thank everyone who showed up live, everybody who asked the questions that led to the creation of this talk. Well, what I was struck by, Tio, is that it seems like 90, maybe not 90, a large double-digit percentage of the time, of the things that you could possibly troubleshoot in a situation have actually nothing to do with temporal, right? They have to do with the API that you're trying to call, or they have to do with the database getting overloaded, or like these kinds of things. Is that true to your estimation, that like part of your process when you think about this is like eliminating temporal things from the, or looking at other factors?
Yeah, I mean, Temporal is an orchestration engine at the end, and the things that you orchestrate are important to understand, and will affect a lot of things that you do. And also, given that your workflow code and activity code run on your premises, so on your computer, not running on cloud, and Temporal does not run your code, there is still a factor in Temporal of of that as well. And it's an integral part of your workflow executions that you run on and you control. So those two, all things combine, orchestrating downstream services, but that's what you get. Like, you have a highly scalable, fast orchestration engine that's also polyglot and gives you all the resilience, to go with it but even if you didn't use temporal, for example, you would have to think about a lot of these things. So it's not even related just about temporal, but at the same time, like if you use temporal, hopefully, for many of the reasons to orchestrate the services, then this gives you all the insights and you get visibility, you get alerting power, you get logs, you saw all those different rate limits that you get out of the box, all these features that you get that you might not have otherwise. So it does help with a lot of stuff. But yeah, it's a lot of stuff that's not related directly to what, temporal
Yeah,
is.
yeah, that's cool.
You're
I
right.
have one last question for you, which is, if you use Temporal Cloud instead of self-hosted OSS, how much of what you just covered goes away? Is all of it pretty still applicable, or is there some of it that's just like, whoop, you don't need to care about that anymore?
Uh, well, I mean, all we talked about a lot of the server metrics and making sure you scale up your cluster, that you don't hit your RPS limits, blah, blah, blah. If you're on cloud, number one, that is done for you. So if you hit any of these limitations, if you run into issues specifically on a lot of different things, um, you don't have to worry about it. You open a support ticket and we will take a look and we deal. Another thing is we have a lot bigger, for example, just the database itself. You can run into just database limitation during, your on-prem, and yeah, you're gonna start having issues. We can auto scale also a lot bigger on cloud side. So your use case, as it grows over time, it's a lot easier to maintain that on cloud, where on-prem, and I'm a big supporter, like I actually support community and I've had so many customers. So I'm not, again, coming from this from a sales perspective, I'm coming from this from maintenance perspective, where on-prem, as your use cases grow, and your workloads become, we've seen some companies grow 1,000%. And what used to be, let's say, 100 workflows a day became 100 million workflows a day, right? And maintaining your on-prem cluster, your databases, your version upgrades, any issues, it's an additional load for you, where on cloud you can really, I'm not saying there is no problems, especially you still have to tune your workers. You have to understand your rate limits of your downstream APIs. So like 80% of the things we talked about still applies on both sides, but you don't have to worry about that extra, probably the hardest part of it, which is the service maintenance and growth over time and updates and database issues, data loss. Yeah, so it is easier, but to everyone their own at the end. It's like it's your decision in the end how you want to approach, or if you want on-prem or cloud. It's up to you.
Yeah, I'm also not in sales. I'm in community, but I'm, new to things, and I just like to,
Yeah.
parcel some of that stuff up. My last question for you, and then we'll let you go because we're a little over time. What is the spookiest situation you have run into as a developer success engineer? Like a bug that still haunts you, or something that was particularly gnarly that led to kind of a cool outcome? I don't know. That, like, interpret the question as you will, but what's the spookiest temporal problem you've ever had to debug?
Uh, I mean, honestly, like one that it maybe, I don't know what spooky is, but we talked about this activity timeouts.
Mhm.
That actually, I will never forget, we had a large customer a couple of years ago where they ran into it and we didn't fully understand why yet. We didn't know like what metrics to look at. We learned a lot along the way. So from when cloud started, and okay, it could be just me because I learned over time over those 3 years at Temporal too. But we did have a situation where similar to what we talked about, where a very large customer said our workers stopped picking up activities, and we were scrambling left and right to figure out why. And he ended up being exactly the thing. Their downstream service start blocking, their workers stop picking up activity tasks, and their workers stop pulling, doing anything. and figuring that out, and that's why we even call them zombie activities. Okay, there's spooky. There's a spooky
Saying
name.
zombie activities. I
Yeah,
mean,
there you go. So that's probably like in the spookiest, but that's what actual coin that we use internally, and we should probably name it that in community as well. It's a cool name, but that
yeah.
that that came from that. So
I've got my Halloween costume tonight. Thank you.
there you go. So
So what
zombie.
is a zombie activity?
It's basically an activity that keeps running on a worker and never completes.
Hmm.
In our case, what we talked about in the slides, it could be an activity that calls the downstream service that starts never unblocking that call. So that was the case in this customers. They were calling some downstream APIs, and the connection was just staying alive and never completing, returning a result. And basically, it's an activity that just lives on a worker and does nothing, basically doesn't live, it's no longer alive. It's basically canceled. I guess that's why it's called a zombie, but it's still there. So yeah, that's what it is.
All right. Well, with that thrilling ending about avoiding zombie attacks and all that kind of stuff. Hey, I wanted to thank you so much. Looks like some folks came, asked questions. We're got a recording of this coming up, and then we'll also put it into some kind of a text format so folks can search for it and things. And I just want to call out, well, as I was like, normally during these, I can like kind of Google things as you're going and sort of paste some links in here. There's a lot of stuff you're talking about in this talk we don't seem to have, or at least I wasn't adept at finding existing resources on. So I think this is going to be a really helpful thing to put out there for people. And now, hopefully, from now on, when you're you're in the situation you're answering these questions, you can just link to something instead of like, we'll see. But anyway, I wanted to say thank you so much for coming and doing this, and thanks to everyone who showed up. And we'll I'll post in the Slack when everything is ready to go. So thanks so much, everyone.
All right, bye.
All right, bye bye.